my name is Sagar.
And I'm Yootak.
And over the past few days in our robotics class, we've been creating a robot called the hands-free shuffler. Ironically, you do need hands to split the deck, but essentially it does work as a shuffler.
So before I forget, who here enjoys playing cards? Alright, that's why I built our robot. Our robot shuffles cards by having two motors run separately. So our original plan was based on this picture. The deck will be kept in one place, and then the motor would run to send cards out to that platform, and then the platform would be pulled back in order to reshuffle, and this will be done multiple times. So we got feedback from a few people, and most people said that they liked how our robot shuffled cards, but they wondered how it would do it and how it would pull the cards back for reshuffling. And the main suggestion was that we should attach the motor by using a barrier. So, we made a new plan because we thought that our original one was too difficult and it would take too much time to build. So this new plan uses two decks instead of one, and the motors would still run to send the cards back to the pod. So basically, we had two roles and we each did one. Sagar designed the robot and built it and improved the structure after test. And I basically programmed the robot and adjusted the values for motor speeds and wait time. So this was our pseudocode. Basically, we just used a while loop so that our motors would run while a color sensor read the cards. If there weren't any cards, then the motor would stop. So this was our actual code. Instead of a color sensor, we decided to use a touch sensor based on the bump setting. So if the get bump value was odd, then the motors would run. But if the value was even, then it would stop. So basically, left motor runs first, stops, and then the right motor starts, and then that stops. So in order to start the program, after starting the program, you press the touch sensor once, and then twice while stopping. So this was the beginning of our building process. We made it a design from scratch, and we decided to start with a central structure based on the simple square base connected by Legos that would act as support for the Lego brick.
And so as we were building it, we realized that we need a place for a brick, and we wanted to keep it clean and neat. So we decided to put the brick in between, and then we added the little rectangular Lego pieces so that when the cards slide, they would slide in together. And we started working on it, so we got the platform done, and then as you can see, above the rectangles, we added little other Lego pieces so that the motor underneath could fit. But that idea slowly changed because it didn't work out. So as you can see, the motor, we got it to go under, but when we tested it out, it didn't quite work. Either too many cards would come out or no cards would come out. So we changed our whole design and we made a whole new platform, and we took that off. And so we got it to work on one side, but it was a little slow, but it worked. So we slowly tried getting the speeds faster, making the angle higher so that when the cards fall, they would fall in place and not flip over. So we started working on the other side, and we finally finished the other side. And we also realized that if we have one side's angle higher, it would work better, so that the cards can slide over and they wouldn't hit each other and get stuck. So we did that, and we had to make a lot of improvements mechanically. Some of them we had to do were making it more stable, because that was the main part that affected us, was making it stable so that the cards wouldn't move too much, and yet they would be blocked by the barriers. Software challenges we had were making the motors at the perfect speed. That took a while because we were trying to make it as quick as possible, also to where it wouldn't mess up. So we had to change the sleep times and the motor speeds to a time that was perfect. Hardware challenges that we had were making it stable, mainly. So the barriers would not work all the time, so we had to fix that as well. Yeah, so those were the hardware challenges. And if we had more time, we were planning on putting a color sensor so that when the cards are done, the robot would stop the motors right away. We didn't get time for that, and we also wanted to do a claw so that the claw could pick up the cards, so it would totally be a hands-free shuffler. And our inspiration, well, who doesn't like playing cards? So we were inspired by our great professors. We were taught many things, so That's basically our presentation.